Okay. Show me.
Hi there guys, welcome back to the DashC channel for part 5 in our build series of this, the GEPRC AX5 monster quadcopter. Now in this episode we'll be looking at the firmware, and that means the firmware of the ESCs and the flight controller, BetaFlight in this case. The video will be primarily about this quadcopter, but it should be a general purpose software setup in case you've built a quadcopter, or if you've bought a ready to fly and you want to update or at least check if all the firmware and settings are up to date on your quadcopter, right? So we'll be going over that in detail. Now the first thing we need to do is get rid of these propellers here, because during the setup procedure we'll be spinning the motors, and safety first obviously, so first thing first, we remove the propellers. Okay, once you've done that, we are ready to connect the quadcopter up to our computer, and obviously these flight controllers here have an USB port, so we'll go and connect it up to our computer now. Let's go. Alright, the first thing we want to do is check the firmware on the ESCs. These are BLheli SESCs, so we'll be needing the BLheli suit. If you Google BLheli suit, you'll be able to locate that if you don't already have that software. And the next thing we'll do is set up the rotation direction of our motors. Obviously very important. So we start the BLheli suit. There. Hartstikke. Now we connect the quadcopter via the USB port to our computer, and we power up our quadcopter as well. Otherwise the ESCs won't be powered, right? So we connect up a LiPo. There we go. Our quadcopter comes to life. Alright, the BLheli suit. At the bottom you need to select a COM port, and in my case COM port 11, the baud rate of 115200 is correct, so we go and connect. Hartstikke. It's connected, but it hasn't read the values currently on the ESCs yet, so we do that with this button over here, read setup. Hartstikke. And apparently the firmware on our ESCs is 16.6, as you can see here. Okie dokie. Okay, so at this point we're gonna check if there is an update to that. There's a good chance there is if you've bought ESCs. So flash BLheli, this button over here. Hartstikke. Okay, and well, guess what? The current version I have on these ESCs is the latest version, as you can see. There is no newer update. However, I'm going to show you what happens if you update your firmware. So I select the newest one here. It's a bit hard to see, blue with purple letters, but I've selected the latest one. And I say OK. Warning, yes. And there we go. It's writing the firmware to the first ESC. Hartstikke. Now it is asking us if we want to transfer the old settings of the ESC to the new setup, and we do. So you click yes. Okay, at this point you might think you're ready, but you're not. You've only flashed one ESC, so you do this whole shebang for all your ESCs. It's the same thing for every ESC.
Okay, we are done. We now know that the firmware on all our ESCs is the latest one, which is great, and that's also important because if you want to use D-Shot, you want firmware at least firmware 16.5, I think. So with 16.6 we are good to go if we want to use D-Shot, and I will on this setup. Okay, with that all said and done, we now want to check the rotation direction of each of our motors. And for that we go to the Motors tab in this here program. Now in this tab you first want to click I understand the risk blah blah blah, propellers have been removed. Yes, they have. So we click that, and now you can with these 4 sliders rev up every one of your motors. So the first one will be your rear right motor, and if we move this on up, that motor will start rotating. Now the only thing we do here is check if the motors are spinning the right way around. So what I do is just hold my finger to the side of the motor like so. I hope that's visible. Rev it up, and then you can easily feel if your finger is being slightly pulled away from you or it's pressed towards you, right? You can also see it because the motors aren't spinning at a high rev. Sorry. So that's what you do for each motor, and by then you know if any of the motors need reversing, right? And to reverse motors you return to the first tab over here, and by arming the motors we've now disconnected. So we read this setup again. Okay, now you want to select the ESC that needs reversing. At this point all ESCs are selected, so we'll deselect them like so, and let's say motor 1 needs reversing, right? So I select motor or ESC 1, and over here you see a setting motor direction. Depending on the version you're running, the position of the settings might be a little different, but motor direction is the setting you need. And it's, at this point it is in fact reversed, so we click let's see, normal. That's what you want, or reversed, one of the two. So that's what you want, normal or reversed, depending on if your motor needed reversing. And once you've done that, you click the right setup. I'm not going to do that because my setup is already correct. So that is basically everything we need to do at this point in the BLheli suit. We don't want to tangle with the ppm min throttle, max throttle, especially not if we're running D-Shot, but if we use, for instance, one-shot 142, we'll basically take care of that in the BetaFlight software. And that's where we're heading right now. So at this point you can basically close up the BLheli suit and run BetaFlight. Alrighty, the BetaFlight setup. So we're moving to the firmware of our ESC now, right? Now if you don't have BetaFlight already, you simply search for BetaFlight configurator. If you'd only search for BetaFlight, you'd wind up with the actual firmwares. That's not what you want at this moment. You are looking for the BetaFlight configurator, so the software you use to set things up. And that is a Chrome application, and the first find we see here is the one you want. And you can, well, I've already installed it, so I can launch the app if I want, and well, actually I do. So here we go. We are now in BetaFlight, and let's see. I do still have my quadcopter connected via the USB cable. I don't have the LiPo connected anymore though. not needed at this point. So we go and connect. Okay, so we are now connected to our quadcopter, and the first thing you want to do here is find out what kind of firmware this flight controller needs. What build of firmware this flight controller needs. So we go to the CLI tab over here and we type in a version, and we see that this flight controller expects an Omnibus F4 firmware. Important, because if we want to flash a new firmware onto this flight controller, we need that specific one, maybe a newer version, 3.1.8 or whatever, but none other than the Omnibus F4, if that makes sense. I hope so. So, well, I'll show you what that looks like. I now disconnect, and we go to the firmware flasher. Now I already have Omnibus F4 selected over here, and that's what you need. Next thing you do is see what the current firmware is, the latest one, and well, what do you know, 3.1.7 is the latest firmware, so I have no need to update that, right? If I'd want to update the firmware, I would now have to disconnect my quadcopter from the USB port, and all flight controllers have either a button for the bootloader or a pad that you have to short out. The documentation for your flight controller should contain info on that. My flight controller is, well, with the frame on, it's inaccessible, but it has a little button, and what you do is you hold on to that button, then connect it up to the USB port. Then your flight controller is ready to accept a new firmware. So, yeah, 3.1.7 is already on there, so I won't be flashing things. But if you want to update, you then say load firmware, and what that does is it downloads the firmware you selected, the Omnibus F4 version 3.1.7 in this case, and it downloads it to your computer, your local computer, which it has now done. Then I can go ahead and flash that firmware onto my flight controller, which I will not do, obviously, because I already have the current version. But if all is well, you'll see a progress bar over here, and it'll flash that new firmware onto your flight controller. And after you've disconnected and reconnected the USB cable, you'll be able to then connect with BetaFlight and see that you have that new firmware on your flight controller. Okay, in some cases you need to set a lower baud rate over here. Some flight controllers don't like a very fast connection speed. The documentation on your flight controller should contain specifications on that. Otherwise, just try a lower speed until you do get to flash that firmware onto your flight controller. That's about it for flashing the firmware. If you run into problems with this, hit me up a comment down below and I'll be happy to answer you. So let me see, I can now connect to my flight controller again, and we go to the CLI tab again, and we type in version, and if you've updated the firmware, you should now see that new firmware version over here. Okie dokie, the next thing we'll do is we'll check if the receiver works, and we do need to connect up again. There we go. Obviously you need to set up a port for your receiver to connect to. Now a lot of flight controllers have a dedicated S-bus port, right? Basically all that I've come across. So if you've connected your receiver to that port, in most cases you will have your receiver connected to UART1. Not in all, but most cases. So, in that case you have to set serial RX for UART1, as I have here. That will enable you to use your receiver, so to speak. And the next thing we'll do is we'll go to the configuration tab and scroll on down to the receiver portion over here. Select serial based receiver. SBus is a serial protocol, and over here select SBus, and we then save and reboot over here, the button on the lower right. Okie-doke. Now at this point your receiver is probably not powered up because our LiPo isn't connected. So if we move on to the receiver tab, and I'll switch on my radio. Well, actually in my case, well, that's a bit of a bonus, but the receiver is powered up if I only have it connected to the USB port. But as you can see, I can move the channels around if I move my sticks. So that's great. Yeah, that's a bonus for me. If that does not work this way for you, you probably have to connect up a LiPo to have your receiver power up. Okay, so in this page over here, the major thing is to make sure that the range of our channels is what we want them to be. And that means that at least the first 4 channels move from 1000 as you can see, center up to 1500 approximately, but as close as you can make it be, to 2000 approximately, give or take 1 or 2. Okay, and that's basically a thing you need to set up in your radio. The first thing you want to do is center all channels to 1500 with your sub trims, and I won't show you how that's done because that's different in every radio. But again, center up the sticks and then use your sub trim to move each of the 4 first channels to 1500. Right? The next thing you do is make sure that the lowest number is 1000 or approximately, give or take 1 or 2, and the highest number is 2000, give or take 1 or 2. And that's done with the end points in your radio. This is pretty significant stuff, so take your time for this. Might take you a little while to get every channel set up right, but it is important. Now obviously you also want to check if your aux channels work, and those you will need, for instance, for your flight mode and to arm and set a beeper. I've set up 2 flight modes, 2 aux channels, as you can see. But well, you can set as many as you like to a certain degree, depending on the receiver you use, of course. But well, I basically use only 2. Okay, congratulations, we are actually pretty far on our way of getting to a flying quadcopter. Now let's see, what shall we check next? Let's check the orientation of our flight controller. Most flight controllers have a little white arrow printed on them, stating where the front of our flight controller is. If for any reason you've mounted your flight controller in another orientation, maybe that made more sense for your build. The wires might have been easier, the wiring might have been easier. So we have to at least check that. So if we are in the first tab of BetaFlight, the setup tab over here, and if we move our quadcopter around, the diagram in the center of our screen should look exactly like we are moving our quadcopter. And if that is not the case, we need to go to the configuration tab over here and over here. Oh, this has actually been moved, as you might have noticed. This was previously on the left of the screen over here, but it's now over here. Over here you can adjust for the orientation of your flight controller. Maybe you've rotated it around 180 degrees, then you'll have to enter 180 or a minus 180 over here. Maybe your flight controller is upside down, man. Then you get a 180 over there. So yeah, I've mounted my flight controller the right way around, or the right way around, the way the manufacturer intended. So I don't need to enter any adjustment over here. You might, and well, try it a few times, and you will easily see in this page if you've set that up correctly. And if you have not set that up correctly, if you forget to check this, your quadcopter will fly very, very horribly. You'll have an instant flip. So if you power up your quadcopter arm and try to fly it and it instantly flips, this might be the cause. Second thing we'll do is we'll just run on through the entire configuration page to see if we need to change anything over here. Now, because we've updated the firmware on our ESCs to 16.6, I can now use, at least in the case of my flight controllers, use D-Shot 600. If you have older flight ESCs, you might need to use one shot or 125 or 142 or multi-shot. Yeah, depends on the flight the ESCs you're using. On most modern ESCs, the latest ones, you can use D-Shot, which is a digital protocol. Your flight controller will no longer talk analogically to your ESCs, but in a digital protocol. So let's see, the next thing, motor stop. Yeah, I always disengage that. That means that if I arm my quadcopters, my propellers will spin. And yeah, that works out best for me. And let's see. I'm only gonna tell you about things you really need to know to get your flight, the quadcopter up and running. We're not gonna be tuning things, that might be something for a future video. We first wanna be able to at least hover it successfully. So let's see, the frequencies, the system configuration frequencies, gyro update frequency, pit loop frequency. Now basically you want to have those as high as possible until your CPU load over here, the CPU load, gets too high. You don't want that to be, with the latest versions of BetaFlight, I wouldn't want to go further than 50%. 50% is stretching it already. And I'm at 8 for both, and as you can see my processor load is very, very low. You might want to switch, if for instance you have an F3 board, to 4K for the gyro update frequency and 2K. For instance, just try and see at what numbers your CPU load will be acceptable. Okay, moving on down. A name, personalization. That will show up in your OSD if your flight controller is an omnibus flight controller with integrated OSD. So this will be displayed in my OSD screen. Camera, not important. Okay, receiver, we have already set that up. I don't have a receiver that tells my flight controller an RSSI indication. You might if you run an FR Sky system, so in that case you'll have to engage or enable this setting over here. Moving on down, we obviously don't have a GPS. And let us see, what are things we need to do? Yeah, oh, and if you have an FrSky system, you probably want to set up telemetry. I don't. LED strip, yeah, my quadcopter has a programmable LED strip. So in my case, I want to enable this setting. Display, probably not. Black box, yes, if your flight controller has an SD card slot or onboard memory, you want to enable black box, and that will then log in-flight data, important for tuning. Transponder, yeah, if you're running races, you might have a transponder in your quadcopter, so you want to enable that. Air mode, yeah, you can set up air mode in two ways. As a feature over here, and that way the air mode feature will also always be enabled. I don't want that. Should I tell you why? Yeah, this might be not beginner or intermediate stuff, but air mode, if I enable air mode over here, air mode will always be enabled, even if I run into a fail-safe condition. So for instance, if I lose connection from my radio to my receiver, I'll then run into a fail-safe condition, right? And in that instance, I don't want air mode enabled. Yeah, maybe for instance, if I pick the quadcopter up and stuff, or if the quadcopter lands upside down, in those cases I don't want air mode. So I always use air mode as a flight mode. Okay, and SD card, well, if your flight controller has an SD card, you want to enable this. If your flight controller is an omnibus or you have another kind of OSD connected to your flight controller, you want to enable OSD. I do, so I have enabled that. And that's pretty much it for this page. Okay, pit tuning. We'll leave this entire screen alone for now. Remember, we first want to just see if the quadcopter flies at all. So we don't need to set up anything. If you're an advanced pilot, you probably go and set rates at this moment. I won't. We first want to see if the flight controller, if the quadcopter flies. Receiver. We've already looked at this. We know that the endpoints of all our channels are what we need them to be. So that is great. Modes. Now I've set this up a little different than I usually do. Just for illustration for you at this point. I've set up 3 flight modes. And they are over here. Angle, horizon. And if none of those are selected, we are in acro mode, right? And I've also enabled air mode, but only for horizon mode, like so, and acro mode, right? Well, to be honest, I don't use angle or horizon mode anymore. I simply have one flight mode, the first without air mode, and the second 2 are with air mode, and the third one is air mode and black box logging on. That's what I have, but for beginners and intermediate flyers, I think this is a good setup. So again, the first flight mode I have is angle without air mode. The second one is horizon, semi-auto level mode with air mode, and the third one is acro mode with again air mode, right? And let me see, what more have I done? I've got an arm switch there on a second switch, and in the middle position of that switch, the aux2, I have a beeper set up there. See, my LiPo isn't connected, so it won't beep, but yeah, that's what I use my aux2 for. This is a good setup. I think this way, if I touch my arm switch, the quadcopter will first beep as a audible confirmation that I've used the right switch for that. I hope that makes sense. Now let us see motors. Yeah, basically if you are running D-shots you don't need to calibrate your ESCs. If you run older ESCs you probably will have to calibrate the ESCs. Now there are already so many videos on calibrating ESCs. Apart from that, it's also very simple. I'll skip that for this video. I don't want to waste your time with another video on calibrating ESCs at this point. Okay, the next screen, OSD. Yeah, if your flight controller has an OSD, you can obviously set that up to your liking. Not important to get the quad flying for the first time, to check if it flies at all. So at this moment we'll skip that. The LED strip, yeah, very important to see if the quadcopter flies, so we'll skip that as well. Black box logging, yeah, it is handy to set that up, of course. I have an onboard flash, I set it to 2K, and in the configuration tab we've already enabled this, so it will log your flights. So that's good. And that is basically it, at least to get the quadcopter hovering. So at this point we can disconnect. Now I want to draw your attention to something not important to get your quadcopter flying, but over here in BetaFlight is a donate button. And if you have bought a brand name quadcopter like an Immersion RC quadcopter or something like that, you can be pretty sure that the company manufacturing that quadcopter has in fact donated. They have probably paid BetaFlight for every single flight controller they ship. However, with these Chinese flight controllers, or at least the flight controllers you buy from places like Banggood, which I have in this case, there is a list with links to all the hardware in my quadcopter in the description down below. With those flight controllers, I'm not so sure if they have set aside a certain amount and pay that to BetaFlight, the BetaFlight team. So you tell me, do you want to donate? I always, for any flight controller I source from Banggood or GEPRC or something like that, I donate 5 euros to BetaFlight. I think they've done a very good job at progressing this hobby, so I value that highly. Okie dokie, so the base software setup is done for now. So you're ready to reattach your propeller. So yeah, the propeller at the right front is a propeller that will spin counterclockwise, that way around. Not unimportantly, of course, and the propeller at the right rear will spin clockwise, like so. The propeller at the left front will also spin clockwise, and the propeller at the left rear will spin counterclockwise, like so. And with that we've come to the end of this video. I very much hope this video helped you out. If you are left with questions, again, don't hesitate to hit me up a comment down below. I'm sure I'll be able to help you. And yeah, I hope to catch you on the next video. Bye bye.